non-metallic elements found in cells in periodic table.
Okay, so we're non-metallic.
Very reactive.
Very reactive. And usually form salts. Okay.
Basic information that was very active and combined with most elements from around here.
Okay. Now, remember we talked about you had the alkalis that were very reactive, and now we have the halogens that are very reactive. Now, the alkalis want to get rid of one electron, so that's why they're readily, and they just want to get rid of it as fast as they can. The halogens are short one electron, so they're willing to take it from anybody that has an extra electron. They're willing to take it from them. Yeah. All right, so that's why they're super reactive. And most of the times what you're going to get is the halogens matching with the alkalis. And that's how we get the salts. Okay? Remember we talked about the other day, sodium chloride is table salt, sodium from the alkali, chlorine from the halogen. So they're very reactive. What happens when you send an electrical current through the halogen? Some of the uses for halogens, halogen lamps in your headlights. And so those are usually filled with the lower level. So as you go down that column, it's usually filled with some of those gases. And then by sending an electrical current through them, they actually react very well. You get different colors. And each, it's very similar to the neon, which are actually the noble gas, but very similar to the way they work. All right, finally the last one, inert gases, also known as noble gases. I wish you guys know that term, inert. So Tyler, what did you guys come up with for the noble gases?
They are colorless.
Colorless, okay.
They're stable and unreactive on account of the maximum. They have a maximum amount of
Yeah, so they actually have their full outer shell already. And that's why they don't react at all. Okay, now I know this is a very small detail most of you guys overlooked. In the video that we saw earlier, he had this little capsule. And in it you saw that very bright silver metal. That's the rubidium. What did he say that the rubidium was surrounded by? What type of air? It was argon. Look at your periodic table. Where's argon? In the noble gases. So what they're doing is they're surrounding it by this inert gas that prevents the rubidium from reacting. If you were to put rubidium in normal air, it's going to react very readily. So they have to surround it by the noble gases to keep it from reacting. So a lot of times when we're storing these alkali metals, especially the very reactive alkali, we surround them with the noble gases. Let's go back to history. Hindenburg, what happened? Yeah, that was hydrogen gas, right? Hindenburg was the big blimp, right? How do we not have blimps exploding anymore like we did the Hindenburg? What are they using now? Helium. Helium's non-reactive. It has a full outer shell. Therefore, it's not going to catch on fire. And it's hydrogen gas is the one you have to watch out for. All right, so basically the key thing there for noble gases, they have their full outer shells, super non-reactive. All right, questions so far in any of the groups?
No.
All right, the last thing I want to talk about is the organization. I want everybody to have your periodic table out. Now, one of the things that you guys probably are not aware of is that by looking at the periodic table, you can actually determine the charge of elements, and it's all based on their grouping. So when we talk about the charge, we're talking about how many extra or how many short an element is from having a complete shell. So we start over here at the metals. The metals have one extra electron, so they have a charge of +1. And the alkalins, they have 2 extra electrons, so that's a +2. And everybody should be writing this down. And then we're going to skip the middle. Remember, the transitional elements don't play by the rules. Iron comes in 3 different forms, which means 3 different electron configurations. And don't worry about trying to stress out trying to memorize all that. That's way above this class. Take Chem 1, you can play through there. And then you have boron that has +3. And so those are your metals. Metals have a positive charge. Now we're going to work from the other side. Your halogens are short 1 electron. Now you see why lithium and fluorine readily react. Okay, that's why all the alkali metals react very readily with the halogens. Okay, they're both +1, -1. Starting at oxygen, we're -2. Nitrogen is a -3. And that applies for all the elements in that column. And then finally we have carbon. The problem with carbon, remember, how many electrons does carbon want in its outer shell? How many total for carbon? I found out this a little bit yesterday. What's 8? If we look at carbon, count across the row. If you want to know how many it has right now, count across the row. 1, 2, 3, 4. So carbon has 4 electrons in its outer shell. Which means it needs 4 more. Or it could lose the 4 electrons. Just right in the middle, it could go either way. That's what we say, that whole column goes either way. It's a plus or minus 4. Sometimes they have a positive charge, sometimes they have negative charges. Now, some of the things that, again, I want to point out to you. You guys notice how I went across the row to figure out how many electrons they had. All you got to do is count. So we're talking about the fact that the first shell had 2 electrons yesterday. We go to the first period, there's 1, 2. So if I ask you, well, how many electrons does zinc have in its outer shell? How would you figure that out? Okay, so I go down here to which period? Second over here.
4.
Period 4. I gotta count over to zinc. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That has 12 electrons in its outer shell. Okay, so that's how we can use that. So any questions on that? Knowing the charges. Pretty basic. Alright, we'll go ahead and finish up there. Yay, that was easy.